If you have any problems with the presentation, with video, or with audio, please let me know via chat. Otherwise, anything else, go through questions, please. So let's go ahead and get started here. Thank you again for attending one of our Lab Chart Mastery series. Today we're going to cover digital outputs and inputs, event manager, and fast response output. Two of these are extensions that can be added to Lab Chart, so they're free of charge, but they're additional plugins that you will need to download and install for your software. And digital output and input are actually pre-built in, I guess we could say, for Lab Chart. My name is David Ream. I'm the technical support engineer for AD Instruments North America, and I am based out of our Colorado Springs, Colorado office. So I've probably spoken to more than a few of you more than a few times. So let's go ahead and move on. And before we get to the actual root of what we're going to cover today, first I'm going to go over kind of the webinar guidelines. As you probably already noticed, all audio from attendees will be muted during the presentation. That's to keep any background noise down so we can stay on track with the webinar and the topic we're going to cover today. The primary way to communicate with me is going to be through the GoToWebinar toolbar. If you're using a Macintosh, the image here on the left will be what you're seeing, and if you're using a Windows machine, the image on the right will be what you're seeing. Not a whole lot of difference there. As far as if you have questions during the webinar, please enter them into the questions box of your toolbar. If you maybe have concerns about audio or video or what's going on, please just kind of put those things into the chat window. Moving on, I'd like to cover a few of the training opportunities we have coming up, and we're also going to talk about a future webinar that's coming up this month. But first, the training calendar. These are actual physical courses we conduct at our locations in Boston, San Francisco, and here in Colorado Springs. So we have a few coming up here for Boston and also for the West Coast. And if you want to come see me and Brandon Boucher here in Colorado Springs, definitely attend the one on the 27th to 28th of February. I normally teach part of that course. And these will take you from the very basic intro to Lab Chart all the way through advanced data analysis with a lot of our modules that are available. So if you're a new user, I highly recommend attending one of these in-person courses. They'll take you from a novice to an expert in a matter of 2 days. So, and we also do charge for these. So contact your sales rep to kind of find out more about pricing and maybe future availability if you can't make any of these. We do hold these throughout the year. And next, I want to talk about the upcoming Lab Chart Mastery webinars. We only have one scheduled right now for this month. There'll be more coming. And if you want to look back, check back later to see the other ones that have been added, definitely go to www.adinstruments.com/events. You can also find out more about our in-person training at this webpage. But the upcoming one is macros, so further automation in Lab Chart, kind of what we're covering right now, but some custom coding you can do to speed up analysis, and it'll be done the 24th of January. And these next couple of slides, just some things we added due to some questions we get fairly common from customers. And you definitely don't have to read all of this. Basically, the takeaway message from this is that our products are not intended to be used as medical devices or in medical environments. For research, yes, but do not use them to try to diagnose, treat, or monitor an actual subject. So, also, about our equipment, what is it approved for? These are the symbols you'll see if your equipment is approved to be connected to a human or for direct cardiac protection. So the little stick figure in the box there means it's approved to be connected to a human, as long as there's no direct electrical connection to the heart. So a lot of you'll see this on our bioamps, a few of our other amplifiers. They're electronically isolated, so there's no risk of actually getting mains power to the subject. And so definitely be sure before you connect to either a student or to a test subject that you have this approval emblem here. And of course, there's the direct cardiac connection that's capable as well. That's the little heart in the box. Last but not least, quality management. More often than not, about once a month, I get a question from somebody who goes, well, how do I know what PowerLab is telling me and what Lab Chart is telling me? How do I know that's accurate? We went through great lengths and expense to get our manufacturing and testing system certified under the ISO 9001 quality management system. So this is an outside organization that comes in and audits what we do to make sure that we're doing the best testing and design to ensure that what our equipment is and software is delivering is accurate. So if you ever have somebody ask about this in one of your labs or anything like that, definitely point them to this. We do have these certificates on our website, so it's a great way to say that, yes, what we know is accurate we're getting from LabChart and Power Lab. And today, this is our webinar program. First, we're going to cover digital inputs and outputs. Like I said, these are built into LabChart. There's no additional plug-in that needs to be added. Next is Event Manager. This is an extension, so it's free to anybody who owns LabChart, but it is something you'll have to download and install. And then Fast Response Output. That is also an extension. It's free to anybody who's purchased LabChart, but you will, once again, have to download and install it. So before we get going here, that's pretty much everything for my little slideshow here. Let's go straight into LabChart. First, I'm going to talk about digital inputs and outputs. What does that mean? And the best way to explain that is actually to go to one of the hardware manuals for a Power Lab. So whenever LabChart loads, every hardware manual for every one of our front ends and devices gets loaded with it. If you go to the Help menu, you'll see that underneath LabChart Help, there's this Hardware Manuals option. If we click this, it'll take a little bit because it uses a bit of JavaScript. We get a search window in Adobe Acrobat asking, well, what do you want to look for? So what I'm going to look for today is I'm going to look for a 35 series Research Power Lab Owner's Guide. So I'm just going to type in 35 series, little search button, and it searches, and we find everything that has 35 series in it. So we have the 30 series, 35 series. We're going to go ahead and go to the 35 series Owner's Guide. I'm going to go ahead and close this and open it. And where I want to go is down here in Technical Aspects. And we'll zoom in a little bit here. So on page 29 of your Power Lab Owner's Guide, it'll talk about digital input and output sockets. These are hardware sockets that are on the back of the Power Lab. Let me go ahead and find that page. So you'll see here on the back, this digital output and input 15-pin D-sub connectors that are on the back here. And here are the actual pinouts of these. And there are ways for you to access the digital input and output features of the Power Lab. It also explains, too, what the digital input lines require. They respond to a 3.3 volt logic signal, so just basically a little spike with a threshold of 1.2 volts, and their impedance is coming in. The digital output lines, it kind of talks about how the pin layout is for them, and also some grounding features available to you, some power pins that are available. And there are ways, the inputs are ways for an external device, say a fluoroscope, say MRI, any other type of machine you have out there in your lab to actually send a signal pulse into the Power Lab. The digital outputs are ways for LabChart and the Power Lab to send TTL pulses or signals, not necessarily, it's just going to be a simple, almost a unit spike that will go out and actually can signal another device to say turn on, turn off, or perform some task. It's just a really simple signal. There's no kind of waveform to it or anything like that. It's just a really simple small pulse. And these are ways that you can both communicate with LabChart and Power Lab, and as well as from LabChart and the Power Lab to communicate with other devices or softwares. As I said, this pinout here is in the Power Lab Owner's Guide, and specifically for the 35 series, our most current Research Power Lab series. It's on page 29. And this will all kind of come clear when I start talking about digital inputs and outputs. So, as I said, we'll start talking about digital inputs and outputs. I'm also going to direct you to, I'm inputting a live video into LabChart with our video capture module. We do have webinars later on that explain more about it, but it's a way to kind of pipe in video into LabChart, record it with a file. But for today's uses, I'm just kind of going directly to a camera that's recording live here. So let's go ahead and let it refocus, and we'll move on to digital inputs and outputs. So digital inputs and outputs, the very basic uses of them, or the very basic setup of them. If we go to the setup menu, you'll see down here is a digital output option, and for right now, the digital output panel is grayed out. For these to be active, your Power Lab has to have digital inputs and outputs. If you're using some of our teaching series equipment, they will not have it, such as the Power Lab 15T does not have digital inputs and outputs, so these options will not be available to you. But Power Lab 26T, our research series equipment, all of them have digital inputs and outputs connectors and the hardware capability. So once again, setup, digital output. If we left click on it, it brings up our digital output configuration. In the most basic feature or function of this capability, we can set up kind of a manual digital inputs and outputs. The Power Lab has 8 digital inputs and digital output pins that are available to us. So for instance, I could create a configuration 1 here where I want output 1 turned on, output 2 to be off, and the green circle here means on, of course, as I said. The gray means turn it off. Whenever I apply this configuration, I want that output to be turned off. White, which is the default setting, means do not change the state. So if I leave white on, or I leave number 3 here with just the white selected, it will only, let's say I have another configuration applied, it will leave it to whatever state it's in. So if it's on, it'll stay on. So I'm just going to have that. I'm going to create another configuration. We have 2 on, and we force 3 off. Create another one. We create 5 total configurations here. Oh, messed up that one. And I'm going to do kind of a reset where we'll turn them all off. And this one is just going to be kind of to show you what happens with the no change, do not change state. So on, off, do not change state when it's white. So what does that mean to me here? I can apply them here, and you'll see I have a little test right here with some LEDs that it's in front of the camera. So output 1 is, or digital output 1 is actually attached to a green LED. 2 is attached to an amber. And you can't really see it very well. This one is should be red. So we've got another amber there, it looks like, and then we can go and turn them off. So what does this do for me? You'll see here too, if they're similar to each other, it shows up as being checked as both being applied. But say, for instance, I apply this one, so you'll see here, we'll turn them all off. If I apply 3 here, we have output 3 turned on, but all the other ones are turned off. We do configuration 5, 1 is turned off, 2 is turned on, but we tell 3 not to change state. We hit apply, and you'll see both LED lights come on. So that just kind of shows you that option here. It just does not change the state at all. It just leaves it as is. So obviously you can go in here, we can add multiple configurations. I can go ahead and apply them here if I want to. If this window is too large, we can hit OK, and we get our digital output panel that shows up here. It just gives us a little smaller version that we can tuck off to the side, and then we can access manually while we're recording. And you can also make that, you can close that, and get it to reappear by going to Setup, Digital Output Panel. It opens up again. So what does this do for me? Why do I want to do this? As I said, we can send signals out to other equipment. We can have signals come in. In this instance, I can manually control equipment while I'm just sitting in front of the computer. I don't have to run over to turn it on. I want a syringe pump to turn on, but it's across the room over by the test subject. I can do that from here by sending a control pulse to that syringe pump if I want to, or to multiple devices. I want that manual control. There's ways to automate this that we're going to talk about later on, but this is the most rudimentary use, very, very kind of simple only manually are we controlling anything. It has to be something that the user does here with a mouse click. And I'm left mouse clicking on these buttons here to apply the different configurations. So pretty simple, pretty straightforward. I'm going to go in here because we could have some kind of conflicts later on with some of the other things I'm using. I'm going to go ahead and delete these. So as you saw, by pressing the positive button, I can go ahead and add them. If I press the negative, I can go ahead and delete them. I'm not having it all. Actually, let me go ahead here and reset them all. Make sure they all turn off. And if you ever forget of what we're talking about or you need help while you're setting up digital outputs, you'll see in a lot of our windows here we have a little hot button that goes straight to the digital output help topic in LabChart help. Oh, let's try it again. Okay. It pops up. And we just have it fallen behind here. So then we can go ahead and look in quickly. It also talks about the different Power Lab models that actually do support digital inputs and outputs. And we'll give you more of the background of what's happening and how to set them up. Next, we're going to talk about digital inputs. Digital inputs are linked to two features. One involves a macro, so if you're interested about using digital inputs with macros, I would definitely recommend attending the webinar on the 24th. The other way that digital inputs are linked is with preset comments. And to access preset comments, we go Setup, Preset Comments, and normally this will be blank. I've just gone ahead, just for the sake of this expediency, gone in and created one. So if I wanted to add a new one, I could go ahead and hit New. It brings up this dialog. And you can set preset comments to a variety of different things. You can use shortcut keys. I can go to the external trigger input on the front of the Power Lab according to how the stimulator is working. But where digital inputs come in is with digital bit and digital byte. Now you'll see here I actually have a test rig that's going straight from the stimulator output of the Power Lab to digital input 1. Whenever there's a connection like this, there's actually an active connection, you can see this shows, okay, that we're in a low state for that digital input. If there's no connection at all, LabChart assumes that they're in a high state. That's just how it's set default. So if I disconnect, we'll go ahead and just move my camera a little bit here. Just sneak peek at another piece of equipment behind me. And I disconnect it, you'll see that digital input 1, the light goes to high. When I connect it, it goes to low. That's just saying we have something connected. It's in a low state. And we can actually tell, okay, whenever we have an input on digital input 1, we can say either at the rising slope of that input or that pulse or the falling input. It'll actually tell us, it'll say, okay, well, I'm going to add this preset comment into the data. Digital byte is a little bit different of an option. Digital byte considers those 8 inputs to actually be an 8-digit binary number. So the possible combinations, 2 to the escape me, 2 to the 8th power, so about 255, 256 possible combinations. So we could link, if we can actually change the digital byte on the inputs, we can have up to 255 different responses from the, or different preset comments linked to this. Today I'm just going to kind of talk about this. So right now you can see we have all high, so 1 and a 0, which equals 254. But to kind of show you how it works, I'm going to go ahead and set it to digital byte. We're just going to drop commenting. Actually, we're going to just go to cancel. I'll kind of show you when we have one that exists, we can delete it or we can edit it. And this is how I have it preset. So I have digital byte whenever we get an input on number 1. On the rising slope, on all channels, we dropped a comment that has a text of comment 1. Okay? So I've set up this preset comment and linked it to the digital input. I need to go ahead and set up my stimulator. I'm going to turn it on, and I'm going to send in a 100 millisecond pulse, square wave pulse at 1 hertz to it. And actually, that should work just fine. So I have it turned on. And as I said, I have a little test rig where from stimulator output 1 to the back of the power lab into digital input 1 is we just have this nice wire loop that's going in there. So whenever I hit start, that will start recording, and we start dropping comments. That pulse is occurring at 1 hertz. So every time we get that TTL pulse that comes in input 1, we drop a comment. And you can see here, all the comments are occurring. We have a slight little bit of software lag, very, very small, 1 millisecond, exactly at 1 hertz. So they're responding to that signal coming in. You don't believe me, say, oh, that's automated here. What I'll do is I'll set up stimulator. I'll set it to trigger manually. Close. I'll open the stimulator settings, stimulator panel. Okay. We'll start recording. Every time I stimulate, I hit stimulate, we send a pulse out. Oh. Let me stop that a second. I forgot to change the stimulator setting. I don't want it to have infinite repeats. I just want to have 1. Go ahead and delete all this. It's going to warn us saying we're deleting some video. That's fine. Start. Hit stimulate. Hit stimulate. There's our comment. So how is this useful? What does it do for me? Say we have that MRI machine we were talking about before, or fluoroscope, echo machine. We want to know at what points in our data it takes a picture, what time point in our data that picture relates to. That's how we can mark this in LabChart. We know the exact time when a certain picture is taken. We can just have this picture 1, picture 2, echo 1, echo 2. So you can actually correspond whatever image you've taken to what exactly is happening in the data or with your test subject at that point. So the digital inputs can be very helpful for you to time sync with other devices. And of course, using this preset comment option. So that kind of takes care of digital inputs and outputs. We're going to move on to Event Manager. Event Manager allows us to get a little more fancy, we'll say, with the digital inputs, or excuse me, digital outputs. And what Event Manager does, just give us clear things up here a little bit, and we'll go ahead and get rid of some of our channels, make things a little easier to see. Okay, and for this instance, let me go ahead here and reconfigure things a little bit. I'm going to take a stimulator output. I'm going to put it into channel 2. And I also have a pulse transducer that I'm going to tap to kind of give us another input on channel 1. So we have active data being recorded. That's going to be recorded in both channel 1 and 2. So Event Manager. How do we set it? What is it? How do we set it up? To get to it and actually find its settings dialog, it's underneath Setup, Event Manager, and we'll get our Event Manager setup window. Once again, Setup, Event Manager, and you do have to have this both installed and turned on via the Feature Manager. There's another webinar that will talk more about Feature Manager and managing the different things in LabChart. That's where you would need to go, just for really cursory touching on it here a little bit. Help, Feature Manager will allow you to get to the Feature Manager. And you can actually, if you have the Event Manager loaded, it will be there and you can turn it off or on. But going back, we're talking more about Event Manager today instead of Feature Manager. Go ahead and open that up. Not very exciting looking window here. It's empty. And the way Event Manager works is we can define events and we can link actions to these events. If you'll kind of see here, new event. The event is the root of everything that's going to happen here. Basically, we're going to build a little outline out here. And we'll kind of talk about, they'll kind of show the different flow of how our events work and what actions they actually turn on or off. Down here, you also see monitor window options. There's a similar to the digital output control panel. There's a monitor window panel for Event Manager that kind of tells us, and we'll kind of talk about that more. These are just the different ways that you can tell it to display information about the events that are being triggered. So show law name, show event status, show disabled events, default window size, just a variety of things here. In monitor mode, we have another option there. So we can actually show monitor window. And we're going to go ahead and say that we want to do that so I can actually show it to you. So first thing we have to do, we want to determine, well, what's an event we want to create. The options that are available to us are level. So whenever data trace in a specific channel actually goes above a certain threshold, we turn the events on. Times, all according to how we tap times, and we can actually make wait periods and have a certain amount of time that the event's going to turn on and a certain amount of time it's going to turn off. Recording, add start and stop of recording. And then there's master alarm. Master alarm is less of an event and more of a way to link a bunch of events together so that when they all turn on, then we perform an action. And we'll kind of just cover that a little bit later here. But the first thing we're going to do here is actually do a level event. So we hit OK. And we're going to go to channel 1. So the first thing we can do, we can name it. We're going to say, we're going to call this pulse event. It's going to be on channel 1. We can set the threshold here. There's a few ways we can do this. I can manually enter it in here, 1 volt. I can tell it, and I can also do it on a rising slope or falling slope. I can tell it to trigger instantly if the level starts above. So when we start recording, if the level is above it, it will trigger it instantly. If we don't have this checked, it won't at all until we actually do have that the crossing of the threshold on the slope that we have set. And as you can see here, we can select a bunch of different channels here. Say I want the event to turn off at a different level. I click this, and then I can actually say, okay, well, I want it to turn on at 1 volt, but I want it to turn off at 2 on the falling slope. And as you've seen here, as I've been changing these values down here in this diagram, it's showing us what we're setting. All the oldies and goodies from the lab chart, from the chart view are here. We can do unipolar, bipolar, invert scale, set scale. We can zoom out, we can zoom in. Everything's available to us here. We'll talk about this in a second with the show selected data. So what do I have set here? On the rising slope at 1 volt, I want the event to turn on. You'll see wherever the event is turned on is this blue box down here. I can also change the levels by left-clicking and holding on the box here and moving the threshold line. Same thing here with when it stops. I can make the event turn off and on the rising slope together, or I can do this as well, all on the falling slope. So it definitely gives you a lot of flexibility about specific periods of your signal that you want to have this event turn off or on. And if I say trigger instantly if level starts above, you can see here it started above, so we're turning it on. That's all it's doing is telling us that. But for our little application here, I'm going to say different. I'm going to uncheck the different end level box, which you can see here. Now when we move the slider, we just move them both, and our event turns on the rising slope and off on the falling slope at the exact same value. Okay, so I'm going to go ahead and move this to a 2 volts should work for us for the pulse. We'll hit OK. And you'll see here we have our event. To show you a little something else, I won't talk about that just yet. I'm going to record some sample data here. Okay, there's my pulse transducer. Just entered that in there. I'm going to select this by left-clicking and dragging over the top of it. We go back to Setup, Event Manager. We go back to the event we made, Edit. You see Show Selected Data. that selection I made out here in the chart view shows up now. So I can actually look at my data that I'm going to be analyzing. If I have some example data, and I can set Event Manager up according to that. So if the little sawtooth wave pattern here just doesn't work for you, and you want to see your actual data, what's going to happen when these things apply, we can do it here. So it looks like it's working fine. We'll hit OK. And we've created our pulse event. Every time we're above a certain level in the chart view, that event's going to turn on. So what does that do? Nothing right now. It won't perform anything. It's just going to turn the event off and on. What we want to do is link it to an action. So you see here, once we have an event, we have this action that's available here, or if I select it. Also, to kind of point out here, you see this checkbox here? If it's checked, that event is turned on. It's going to actuate whatever action we link to it. If we uncheck it, it turns turned off, and it will not actuate the event. That's a link to it here. So off and on. So it's a way, if you have multiple events in here, you can turn them off and on, depending on what you want to do for that day. And that's the specific experiment. So I'm going to go ahead and left-click here on Start. We'll say New Action. We've got a variety of options here, 4 to be exact. Number 1, we can add a comment whenever that action occurs. We can play a macro. So if we have a macro written that does a certain step, we can link it to here. So once again, attend that macro webinar, and it'll kind of pull everything together. We can control a digital output, as I mentioned before, and we can also play a sound. So let's just do an add comment for this one. We hit OK. We could say, well, what's the action name? Say pulse add comment, comment text, pulse occurs. And we can actually, instead of just clicking on start or on end, we can actually select it here as well when we want it to happen, this comment to be placed. We can do it on a specific channel or all channels. I'm going to do it on all. And we hit OK. And you see we're building our outline now. And actually, let's go ahead and do this instead so we can play with more of the features. Then, if I wanted to, I can also link another action. We can link multiple actions to OnStart here as well. For instance, we'll do another new action, and we'll have it play a sound. We can do that once again. We can go in here and start and stop. And let me see if I have my volume up on my speakers. You might be able to hear it. Let's get this as high as we can. You may be able to hear that over my mic. Okay. I'm not sure if you can or not. Try to get as close as I can here. We can link it to any sound on our computer, actually. So these are just ones. This is actually the Windows systems. So let's use that one. That one's a bit louder than my other chime. But you can actually record your own if you want to. If you want to terrify your lab assistants, you can go ahead and record your own voice telling them to stop doing what they're doing if it's not according to how the experimental protocol. We could do a lot of different things here. We can have it do it once, or it can keep repeating this wave until the end of the event. So again, OK. Once again, we're nesting. We're building our outline here. And one last one, we're going to add a comment. We're going to call this one. We can use the same name, pulse add comment, and pulse. Let's use the same format. I'm going to do it on all channels again. Hit OK. It's all ending up there. And if this gets to be too unwieldy, we can't see a lot, we can go ahead and collapse these down. So let's go ahead and just kind of play with this and see what's going on with just this one event. So I'm going to hit OK. We're going to hit Start. And you'll see here that we have the Event Manager monitor up as well. And you'll notice there's this little, it's giving us a data value, telling us, okay, well, we only have one event set here. Green means it's actively monitoring, but it has not been triggered yet. Red means it's being triggered. Yellow means it has been triggered, but is again actively monitoring. So we haven't had the event occur yet. I'm going to go ahead here and tap. Didn't quite make it. Went above, and you see we're yellow now. Every time the event occurs, it flashes red, and we drop a comment, 2 comments actually, and we play a sound. Okay. I'm going to stop this. We'll take a closer look at the data, and you can see pulse start, pulse end, everything according to how we set up Event Manager. So we're going to keep building on a little bit more. I'm going to kind of cover a few of the other options that are available. As far as events, there will be timed. Now let's actually show the recording. I'm not going to build a recording one, but just to kind of show you what it does. The event is active when sampling starts and when sampling ends. It's pretty clear. I don't think we need to cover that. It will cover master alarm, but to do master alarm, I have to create another event. So I'm going to do a timed one. Hit OK. Call it timed event. We can just have it occur once, or we can do it repeating. We can change the time display we're seeing here, minutes, seconds, seconds. So we can actually set an additional delay. So I'm just going to say 5 seconds. So it's going to be 1 second long, and it'll repeat every 5 seconds. Now, key thing to remember here with the repeats, time between starts, not time from end to the next start. So there's going to be 4 seconds between each pulse here. So it'll be on for 1 second over a 5-second period. Just kind of a little gee whiz information there. And we're going to have an initial delay of 5 seconds. So we hit OK. What do I want this to do? I'm going to have it do a digital output. And I'm going to do it on the start. Play macro I won't cover in too much depth, but we can name it, we can link a macro to it, and we can select, if we've written a macro, we can select it from this list. These are ones that are preloaded into LabChart, but you can definitely go in and have it play specific macros. Word of caution with the play macro option, be sure whenever you design your event manager scheme that that you're never going to have a condition where it's going to try to play 2 macros simultaneously. LabChart is limited to only play 1 macro at a time. If you end up trying to play 2 at once, LabChart will error, and it will say, I can't play these 2 at the same time. So definitely something to think about whenever you are planning your event manager program. So for this one, as I said, new action, last one is digital output. Hit OK. Very similar to what we initially set. So let's go ahead and stick with our format that we're using. Add event start. You can see we have no change, turn on, turn off, or toggle. Just as with before, turning on here, where it's the blue box here, it's going to turn on that input whenever it gets here. If you have turn off selected, it's going to turn it off. Toggle means it's going to change the state. So if it's on, it's going to turn it off. If it's off, it's going to turn it on. Toggle can be useful to kind of keep things tight and concise, but I normally just use turn on, and turn off, but it's up to you if you want to use toggle. Additionally, no change, just as it says, no change. Just like the actual white dot we saw before in the digital output setup, it just won't change anything. So no change on these. We're going to turn the green light on. We'll hit OK. Now, of course, we turned it on, so we're going to have to go ahead and turn it off at the end, otherwise it's going to stay on. So my new action, digital output, OK. Green light off. Turn it off, and no change on the others. Hit OK. And we should be set up perfectly now. So if we hit OK now, you'll see, let me make this a little bit bigger, we have 2 events now instead of 1. We hit start. Let's go ahead and make that a little bit smaller for us. Our timed event occurred. We went past 5 seconds, then turned off after a second. Turned off, turned on. And you can see our light corresponds to it. Light on, turned on. And we can also match with our other. And now our light keeps turning off and on. So if we go back to setup, I'm going to cover the last thing in Event Manager, and that's going to be a master alarm. First thing, though, I'm going to change this timed event here a little bit. I want to make that a little bit longer, so we'll do 3 seconds so we can really see. So as I said before, master alarms are events that link other events together. We perform certain actions when all or some of those are actuated. So I'm going to go here to master alarm and hit OK. Call this master alarm. You can see here, really simple, the operators. So if I check these, and however many events I have in here, they're all going to show up here in events. I don't have to check them all. I can just check some according to how they should work. And we have an operator. Any of these events, the OR, so if pulse event is actuated or if timed event is actuated, turn on this master alarm. So basically, it's almost the same as just having those events working. If any of them occur, we end up performing an action we have linked to this master alarm. What I found very useful, and I use master alarms for mainly, is all of these. Both pulse event and timed event both have to be actuated for this master alarm to turn on. So say, for instance, you're monitoring respiration and pulse in, say, a subject, a rat, and we want to know if we over-anesthetize, but we don't want to know just if the respiration depresses or if just the pulse depresses. We want to know if they both do it. If they both do it, then we need to back off what we're anesthetizing the animal with. You can monitor both of those to a certain threshold, and if they both meet the criteria at the same time, then we can have a master alarm, we can have it play a sound, a warning sound, we can have a light flash, something that is a visual indicator that, okay, maybe we need to go here and change something with the subject. What I'm going to do is I'm going to have, whenever these pulse events and timed events both occur at the same time, I want them to get to do something. Okay, so I'm going to hit OK. Looks just like other events, so we can turn it off and on just like other events. And I'm going to have it play a sound. I'll try to select something a little more. Everybody recognizes that one. Whenever you do something bad in Windows, and we'll just have it until the end of the minute. Okay. So how does this work? I'm going to hit OK. See, we have 3 events now. I'm going to start recording. After 5 seconds, our timed event turns on. For 3, turns off. This works as it should. And we're getting a little cross there with the, let's just have it turn a light on. That'll be a little bit easier. Go back to Event Manager. I'm going to change this. Digital output. Okay. A little bit easier for our, we're going to turn on. And we're also going to have to make a new action to actually turn it off. Hit OK. OK. Start recording. Our event turns on at 5 seconds. You'll see it actually turns on. We have our other light coming on as well. Our green light comes on. Now our yellow light flashes every time we trigger that master alarm. Hopefully you can see that on the camera. You can see it flash the bottom light. Ever so slightly. There we go. So, great way to link different events together and to actually either tell our devices do things, show warnings, et cetera, et cetera. So that kind of takes us to the end of Event Manager. And last but not least, we're going to cover fast response output. The reason we develop fast response output, Event Manager is entirely based in, let me go ahead and delete some of this data, is entirely based in the software. Because of this, it is limited by how fast your computer is. Depending if you have a really, really poor computer, I've seen delays from when an event is triggered to when an action is actually performed of up to 800 milliseconds with Event Manager. Obviously, for a lot of experiments, it's going to be way too much of a delay. That time lag there is just too much. So we developed fast response output. As I said before, fast response output is an extension you would download and enable to the feature manager. That's not kind of built into LabChart. But what fast response output does, everything that is used with it, it occurs in the Power Lab, so it's all hardware-based, so it's very, very fast. You can have response times with lags less than 1 millisecond with fast response output. But it has to be an analog input, so like a raw data input to the front of the Power Lab. So for this little experiment, I'm going to go ahead and get my stimulator panel open here. And actually, I cannot use it. One of the kata styles with fast response output, you cannot use a stimulator and fast response output. And I'll show you why in a second. Go ahead and turn that off. We'll go to Setup, Fast Response Output. Once again, Setup, Fast Response Output. And we get the Fast Response Output settings window. Much more, very stripped down compared to Event Manager. We're limited specifically to threshold events. So you can link them either to an analog output, 1 or 2, or a digital output 1 through 8. And the reason that you can't use the stimulator and fast response output at the same time is because fast response output is tied into the analog outputs. They cannot share it. So I'm going to do a digital output 1 here, and we can check this. It says generally output when all or any. So that's similar to that or and statement we had in the master alarm for Event Manager. I'm going to say when all, and I can keep adding criteria here. We can choose up to 4 inputs, even though we may have 4, we may have 6. You're limited to a specific amount with fast response output. And we can select the input that we're going to monitor here. For my example here, though, I'm going to go ahead and you can delete them or add them here with these plus or minus buttons. For my specific application here, though, I'm going to go ahead and just do a threshold above on input 1, and this is where my pulse transducer is. And we're going to go above 2. You can change that value by going up or down. We can move the slider, or we can actually manually enter in with the keyboard. So we just set a threshold event for fast response output. When the data values in input 1 or channel 1 go above 2 volts, we're actually going to send a trigger out from digital output 1. You also see here there's this hysteresis option. What does this mean? This means, let me see if I can get a good cancel out of here and get a little bit of a data trace here. And let us zoom in. Oh, I need to turn off, excuse me, the event manager as well. Let me delete these. Okay. And let's zoom in here. That's really good. Hysteresis, what does it mean? Hysteresis means, say we have our threshold, let me back up there, right here at 0.5 volts. Now you can see we've gone up, and then we've come down, and we've gone below that 0.5 volt option. We may not want it to turn the event or the fast response output off at that point. Hysteresis, it's a percentage value. It's a percentage of the total range that we're recording in, so a percentage of 10 volts. So if it does not go below our threshold of 0.5 volts by more than 10% of 10 volts, it's still going to keep it triggered. It's just basically a way just to account for noise and not to constantly have a fast response output being triggered over and over and over and over again. So it allows you to kind of put a little buffer in. Once we trigger, it has to go below the trigger threshold by a certain amount before it will trigger again. And that's all the hysteresis value does. If you have questions about that, definitely put them into the questions box in the GoToMeeting control panel, or you can actually email me if you have more questions. I can kind of show you a little bit better of what exactly it means. But it's a percentage of total range. That's a big thing to remember as well. So if you're recording at a range you probably shouldn't be, you also use really strange small hysteresis values, and you wonder why that is. And that's why that is, because it's a percentage of total range. So we'll go ahead and reset this. 5% is the default value. I'm going to leave it there. And down here we can actually do different things with the output setting. Fix with pulse, its default of the pulse coming out of fast response output is going to be 1 millisecond. We can wait after the pulse starts for a certain amount of seconds. We can delay the pulse for a certain number of seconds. We can limit the number of pulses. So if I do this, fast response will trigger once, and then it'll never trigger again. We can have it trigger 3 times and never trigger again. 5, 6, whatever you want to do here. By default, it's infinite. So every time it triggers, it's going to send a pulse out. But if we limit it, it's only limited to a certain number. So we kind of have everything set up here. Hit OK. And you'll see, turn it on, be very fast. We get our flashing light there. So go ahead and watch my recording there. Tap. Oops, let's try not to tap. We get our little LED light there. Like I said, very, very fast. It's all occurring in the hardware. So those are just the basics of fast response output there. It's not nearly as complicated as Event Manager. And like I said, it has to be a raw data input, an actual input to the analog channels of the Power Lab. So we're going to go back here and maybe talk a little bit more about it. And as I said, you can set up analog outputs 1 and 2. Any of the digital outputs, you can have multiple ones set up. And you'll notice that when they're turned on, you have this little black dot next to the number. Okay, this is it's monitoring a specific channel, and or channels, whenever those conditions are met, it's going to send out a digital pulse, or a pulse of whatever length you chose. So just for fun here, we'll go ahead and change our pulse width to 1/2 second. Hit OK, start. And our light stays on for 1/2 second now instead of that little quick flash. A little bit easier to see. So those are the basics of digital inputs and outputs, Event Manager, fast response, and communicating with other devices in your lab and kind of bringing their inputs into LabChart, into the data, marking it, or actually telling LabChart when certain conditions are met to tell the Power Lab to send out a TTL pulse to signal another device to either take an image, to inject a certain volume, things of that nature. So it's a great way to automate your lab and kind of bring everything central to LabChart. So you don't have to do a bunch of different setups. Everything can be here in a LabChart file, in a settings file that you're going to use every time, or just for you to create on the fly. So that brings me to the end of everything I'm going to cover today. Let me go ahead and bring my presentation up again. If you have any questions about this or any of our hardware, any of the software, anything that AD Instruments sells, give me a call. That's what I'm here for. Whenever you purchase our equipment or our software, you buy my services for as long as you own it. So definitely give me a ring. As I said, my name is David Ream. I'm based out of Coral Springs, so we're on Mountain Time. You can reach me at this telephone number, 888-965-6040, extension 204. I'm on Skype all day, and my Skype name is adi.support.us. So if you maybe aren't near a phone, but you do have Skype on the computer you're on, definitely look me up on Skype. Ask me to add you into my contact list, and we can talk via Skype. Also, you can email me. My email address is my first initial, D as in David, dot, my last name, R as in Robert, I as in Ivan, E as in Edward, M as in Mary, at adinstruments.com. So d.riem at adinstruments.com. So like I said, any questions at all? Any questions about this webinar? You forgot something specific I talked about today, definitely give me a call or send me an email and we can discuss it more in depth. That's everything I have today, so thank you for attending. And I'm going to go ahead here. Let me check the questions box. Either I bored you guys to death or I did a good job and covered everything well for the different things that I covered in LabChart today. I don't have any questions. If you do think of one suddenly before you sign out of the webinar, definitely enter it in there. I'm probably going to leave it open for another 4 minutes, and I'll go ahead and answer your questions in turn. But once again, thank you for attending, and have yourself a good day.